Hey there, future teacher. In this lesson, you will learn the core concepts about number theory that you need to master for your exam. So let's jump straight into this lesson. First up, what exactly is number theory? Well, it's a branch of mathematics that dives into the properties and relationships of numbers, primarily integers, which we discussed in lesson number 1. Next, let's get into one of its key components, which is prime factorization. Prime factorization. Now, imagine a number like 28. It may look simple, but it has a secret structure. And when we find its prime factors, what we need to do is dissect the prime numbers right outside of this whole number, which here is 28. So we can divide by using the factor tree. 28 divided by 2 is 14, and I know that 2 is a prime number, so I'm going to circle it. But 14 can still be divided out as well. And 14 divided by 2 is 7. And there we have our prime factorization. So 28 equals 2 times 2 times 7. Now let's complete another example using 72. Pause the video here. See if you can use the prime factorization using the factor tree in order to find all the prime numbers that make up 72. Pause the video and push play when you're ready. All right, now let's check it together. So we have to figure out two numbers that multiply together that equal 72. In my case, I'm going to choose 4 and 18. And then I'm going to split the 4 by 2 and 2. And I'm going to split the 18 by 3 and 6. And then split the 6 by 2 and 3. And I'm going to go back and circle the prime numbers that we have here. We've got 2, 2, 3, 2, and 3. So I'm going to write my equation down below. 72 equals 2 times 2 times 2 times 3 times 3. If your exam asks you to find the greatest common divisor, let's write that here, greatest common divisor, or another way to say it, greatest common factor between two numbers, remember that the greatest common divisor or greatest common factor is the largest number that divides both without leaving a remainder. We can use our examples that we just completed between numbers 28 and 72. So in order to do this, we look for the numbers that are in common. Here we have a 2, and here we have a 2. And so in order to find our greatest common divisor or greatest common factor, we simply multiply 2 times 2, which will be the answer of 4, which is our greatest common factor, or again, greatest common divisor. These terms are interchangeable. Let's go ahead and work one more example problem to make sure that you're ready for your exam. In this case, let's work with numbers 24 and 30. Pause the video here to see if you can find the greatest common factor between 24 and 30. All right, the first thing that I'm going to do is split 24 between 4 and 6. I'm going to split 4 between 2 and 2, and split 6 between 2 and 3. And then I'm going to circle the prime numbers, make sure all the ends are prime, and I'm going to split 30 by 3 and 10. 3 is prime. And I'm going to split 10 using 2 and 5. And both of these numbers are prime as well. Now let's use a different color to signify in order to find our greatest common factor. Now I see both of our numbers use 3 in their factor tree as well as 2. So what we have to do is take 2 times 3, and that equals the greatest common factor of 6. Your exam will also ask you to demonstrate your understanding all about common divisibility rules. Remember, a number can be divided by 2 if the last digits in the number are 0, 2, 4, 6, or 8. A number can be divided by 3 if that number's sum of digits is divisible by 3, and a number is divisible by 4 if that number's last two digits are divisible by 4, and a number is divisible by 5 if that number's last digit is either a 0 or a 5, and a number is divisible by 6 if the number is divisible by 2 or 3. Also, a number is divisible by 8 if that number's last three digits are divisible by 8. Also, a number is divisible by 9 if that number's sum of digits is divisible by 9. And here we go. A number is divisible by 10 if its last digit is 0.